So far, when we looked at operators such as the plus operator, we looked at them in the context of single numbers. But what about our own types? What if we have a struct called point and we want to add 2 points together? Why shouldn't we be able to do this? And in fact, operator overloading in Rust is precisely the mechanism that makes this possible. But first of all, let's set up a scenario. So I'm going to have point P having x value of 1.0 and having the value of 2.0 for the y coordinate, and let's have P2 being equal to yet another point with the x coordinate of 3.0 and y coordinate of 4.0, for example. So what we want to do is we want to write something like let P3 equals P plus P2. So we want the operator plus to be defined for types of point, and then maybe we want to print line this using the debug output like so. P3. So we want to make this possible. How do we do this? Well, first of all, since I've got debug output here, what I need to do is to somehow provide this kind of debug output. And one of the ways to do it is to just decorate the point with the attribute for deriving the debug output. So I'm going to say derive debug. And that's going to give us a nice output for any point that we decide to print to the console. Okay, so what about the operator? Well, all the operators that you can actually redefine are held in a separate space, and that space is stdops. So this module is what we're going to actually use. So let's add it here. I'm going to say use stdops add, because we need the plus operator. So this is specifically the trait that we need to implement. And then, of course, we have to actually implement this. So we say impl add for point. So we're implementing the addition operator for a point. And to do this, we need two things. So first of all, we need to specify the type of the output that this operator provides. Now, it might seem a bit weird because we're going to have a function later on that actually does this. However, if you look at the actual definition of the add trait, you'll figure out why that is, because the trait has to specify a return value for the method prototype, and it does that using the output. So here we say that the output type is equal to point. That's what the operator is going to return. And here is the operator itself. So an operator is simply a function called add, and it takes, first of all, self, which refers to the point on the left-hand side. So that would be P in this case, and it refers to the other point that's actually on the right-hand side. And obviously the return type here is a point. So in order to return the actual value, the calculation in this case is very simple. We're returning a new point whose x-coordinate is the sum of self x-coordinate and the other x-coordinate. So that's self.x plus other.x, and we do the same for y. So that's self.y plus other.y. There we go. So we are done with the implementation of the add operator in this case, and we can actually run this sample and see what we get. Alright, and here is the output. So we add up points with coordinates 1, 2, and 3, 4. 1 plus 3 is equal to 4. 2 plus 4 is equal to 6. So we got the right result. You're welcome to investigate stdops for additional traits related to the different operators that you can, in fact, overload in Rust. And another thing that I wanted to mention is the right-hand side of the addition does not have to be a point, and that's why there is an output specification here, and also the type argument here. So after add, you can put an optional type argument. So for example, if you want add to be if you want it to be possible to add a point to a vector, you would simply put a vector here, and then you would write the implementation in terms of adding a point and a vector. So that's a small overview of operator overloading.